make sure you pay attention to what I'm talking about, because I will tell you what is my test questions, what is standardized test questions, and what is both. So it will kind of help you out to, you know, to know what's on both. Let's see how many people we got. We got 16. I think that's how many we got in the class, but I want to make sure before I get started. Yep. Well, yeah, 6. There's one that's counting me also, so let me fix that. There we go. Now it should be 15. That's good. So everybody's here. And 1, 2, 3, 4. 1, 2, 3, 4. So everybody is. And Miss Newsom, is that a forehead I see? I will make sure I see. Okay, good. I see a forehead. You're getting pretty close to the ceiling there. You and Miss Williams. But I see a forehead, so as long as I see a forehead, I'm good. All right. So here we go. And I'm going to go to the handy dandy e-book, and there is your first definition. Statistics with a capital S. Write it down and make sure you highlight that S, because let's see if we got any people in here that remember their probability and statistics. Well, so much for that. Hold on. I'm trying to get everything. I usually don't have this problem, but sometimes I do. There we go. There. What is the difference in capital S statistics and lowercase s statistics? Anybody want to give me any ideas? Nobody? Come on, I thought we had some people in here that wrote the book on mathematics. I thought we had some people in here that knew everything. No? Capital S, now I'm going to give you Hubertism definitions. And then if you want to hold your pinky up and impress people, you can read the definition after I give you the Hubertism definition, and you can impress people. Okay? Good job. Somebody answered. They had to go through the chat because they don't want to talk. Yes, it is the collection, calculation, and interpreting data. Capital S statistics is the collection, calculation, and interpretation of data. Now, I've got a question, Miss Jarrett. Where did you get that definition? Because that's my definition. Where did you get that definition?
You mentioned it in class another day.
Okay, thank you. I was fixing to say, how far did we get? Because I don't know how far we got. Can somebody look in your notes? I don't know.
Continuous, I think.
Okay, all right. Well, then I'll just hurry up and go through everything one more time. And in statistics, there are 2 types of groups. There is your population, which is your big group, and your sample. And when you're talking about population, you're talking about the big group, and the sample usually comes from the population. And with the population, you've got to use formulas. And those formulas are going to have variables in them. And the formulas are going to use Greek letters called parameters. Parameters is another word for variables. And with the sample, you're going to use formulas. And they are going to have regular letters, alphabetic, and I can't even spell today, alphabetic, and they are called lowercase statistics. Example, Z is equal to X minus mu over standard deviation, sigma. Z is equal to X minus X bar over S. Now, why do you need to know this? Because if you're given a presentation in the real world or in the future, and they use Greek letters, then you know it has to deal with the what? The population. If they give regular letters, then you know it has to do with the sample. Okay? And it doesn't hurt to review over what we went over last time, because I'm going a little bit faster. And these are 3 test questions. 1, 2, and 3. They usually ask you on a test, standardized or my test, they say what goes with the population and what goes with the sample. That's why I got those 2 together. Okay? So there's 3 test questions right there, standardized and my test. And of course, we talk about the types of data. There's qualitative and quantitative. And qualitative is blondes, brunettes, redheads, or if you want to say green eyes, blue eyes, and brown eyes. These are characteristics. Qualitative data, characteristics, no math meaning. And of course, you want to remember your zip code, your area code, and your social security number. Sometimes a test will try to trick you and give you numbers and you think they're quantitative. Zip code, area code, and social security numbers all are qualitative. They tell geographic location, or, you know, some social security numbers, I don't know if they still do or not, the first 3 letters, what state you're in, but I don't know if they still do that or not. Because the numbers run out, they have to recycle them, so I don't know if they still do that. Quantitative, just like zip code. Somebody remind me, because it used to be 803 or 803 used to be for all of South Carolina. But now, isn't 803, isn't that the low country? I think it is. And then 843 is the Midlands, and then 864 is upstate. Now, I don't know if I'm correct on that, but that zip code area, it tells you, you know, area code and zip code. This tells you the county that you're usually in. This tells you region of a state. And this used to tell you, but I'm not going to put anything besides social security number because I don't know if they still do that or not. Quantitative data is everything else. Math meaning. meaning that you can take the average or the standard deviation or the mean or the mode. Any of those things you can take quantitative data. And that's pretty much everything else. I always tell students this. Ask this question, and I'll put it in red. The average of blank is blank. So, what's the average of blondes? What's the average of green eyes? What's the average of zip codes? Can you do the average of those three things I just mentioned? Yes or no? That's just means shake your head or nod your head. Can you take the average of redheads? No. Can you take the average of green eyes? No. Can you take the average of Social Security numbers? You could, but does it mean anything? No. So if you can't take the average of something, it's qualitative. If you can take the average of something, then it's quantitative. Okay, again, we already went over this because you said that we stopped on continuous, so I'm going to go over continuous and discrete one more time, and then we'll move on. Never hurts to go over something twice, especially when some of y'all don't listen, right? Some of y'all are watching cartoons, probably watching SpongeBob. All right, Squidward and Plankton are my favorite characters on SpongeBob. Any favorite characters? So you're telling me y'all don't have any favorite characters on SpongeBob?
Sandy.
What?
Sandy.
You like Sandy? Oh, she gets on my nerves. I'm sorry. She gets on my nerves. And Patrick should be beaten with a bat with a nail on the end of it. I can't stand Patrick. I can't stand him. Well, we got one person that likes Sandy, and nobody likes any other character on SpongeBob. I appreciate that one person that said Sandy. Thank you for the communication. I appreciate it. The rest of y'all suck. All right, so discrete. And continuous. Some key words for discrete. Count. Predict. Pattern. Locate. Those are some words for discrete. I know why y'all don't like SpongeBob, because y'all like the Wiggles and the Teletubbies. That's why y'all don't like SpongeBob. I would not let my children watch 3 shows. 1, Teletubbies. I would not let my children watch the Wiggles, and I would not let my children watch Caillou. Well, there was something wrong with that kid. Something wrong with that kid. Measure.
You have a work email.
Cannot predict. Cannot locate. And there is no pattern. Also, these are what you call in algebra rational numbers, and these are called irrational. Anybody agree with me, Caillou? There's something wrong with that kid. Nobody? Okay, one person.
Yes.
Okay. There's something
That was
wrong.
my favorite show.
1, he never did grow any hair, and 2, he was a spoiled brat. What'd you say, Miss Newsom?
That was always my favorite show.
Oh my gosh, no. That kid was a spoiled brat. Mom and daddy, I mean, everything mom and daddy was bowing down and doing for him. No. Anyway, I'm sorry. I'm sorry that's your favorite show, but I couldn't deal with that one. All right, so I'm going to go to my handy dandy calculator, and we're going to take 2, and we're going to raise it to the 4th power. Discrete or continuous? That means I want somebody to say if it's discrete or continuous.
Continuous.
No, it's discrete. Why? Because you can predict it. Nothing's going to come after that 6. You're done. So 2 to the 4th power, that's an example. How about 1 divided by 3? Can you tell me, is there a pattern? Can you tell me what the next digit is? Yes, so that's discrete. How about 1 divided by 2? Discrete or continuous? Discrete or continuous? 1/2.
Discrete.
Discrete. How about 4 divided by 2? Discrete. All right, so let's do some non-discretes. Let's do some continuous. How about 2 raised to the 0.5 power? Continuous. Why? Well, somebody tell me the next digit after that 2. Without a calculator, tell me what that next digit is. You can't. Why? Because there's no what?
Pattern.
There's no pattern. There's no repetition of the 3s. You cannot tell me what that next digit is. Now, if you have a super calculator that can calculate 15 digits or 15 decimal points, you can. But for the naked eye, you can tell me what this next digit right here is, but you can't tell me what this next digit is. And that's the difference between rational and irrational, or discrete and, so let's try 7. 7 to the 0.5, or the square root of 7. Can somebody tell me what comes after that 1? No. How about pi? Can somebody tell me what comes after that 4?
No.
No. So all 3 of those examples are continuous. So let's talk about real world things. Eggs, cars, blondes, brunettes, redheads. All of those are what? Well, I put them on this half of the, so they're
Discrete.
discrete. Then what is continuous? Meters, liters, and grams. And we went over this because y'all said we went over discrete continuous. What does meters represent? Length, Hubert. That's right, class. What does liters represent?
Volume.
Thank you. Now, I need to warn you because everybody's weaned on a pickle and you're not supposed to communicate with me. Please don't get beat up after class if you do communicate with me. You might want to watch out because the class is like don't communicate with Hubert. So what does grams represent?
Wait.
Wait. Can anybody tell me what those three things have in common besides continuous? What do those three things have in common?
They all measure something.
Good job. Measure. Now, somebody tell me why I give y'all these two good examples, and then I asked you on a test the height of a tree, and 15 people get it wrong out of 30. I don't know what to say. I mean, I've told you that you count this and you measure this. And I asked you on a test, what is the height of a tree? And y'all say it's discrete. So I need somebody to explain that to me. Some of you foreheads. I love the foreheads. I mean, there's 5 or 6 people with just foreheads. Join the club. There we go. How you like just seeing a forehead? How you like that? Heck, let's just go ahead and just do the ceiling fan. I don't understand y'all. All right, so everybody good? Try to get you to communicate. You don't communicate. Try to get you to show and be proud of yourself, and you give me a forehead. All right, so let's move on. I think we're probably, I don't know, how far was that discrete? Anybody got a page number on that? Let's see. Okay, qualitative, discrete, continuous is after that. There's discrete and continuous. Here's some more examples. Distance, number. Hell, they're giving you the answer right here. Number of heads. Number of cars. Discrete. The distance. Continuous. Don't feel bad. I know a couple of teachers that teach Math 120 at the Pendleton campus, and they could lobotomize students just by discrete, and so don't feel bad. If you never understood discrete and continuous or rational and irrational, don't worry. You're going to have some teachers that will confuse you over the simplest things. I hope I don't. If I do, then I suck. All right. Now, I'm going to go over this, but this is standardized test stuff. I'm not going to test you on this, but I need you to write it down. Nominal. I'm going to write it down with you, but I'm going to do a little bit of, hold on a second. Let me see if I can move this up a little bit. No, it's at the bottom of the page. So I'm not going to be able to move it up. Nominal is the umbrella. Everything is nominal. Everything. The number of days you study for a test, that's nominal. The number of people that have red hair, that's nominal. The temperature of the last week, the average temperature of last week, that's nominal. All of those are nominal. So nominal is kind of like the big umbrella. Everything is nominal. Ordinal. All you got to remember is one word for ordinal. What is that? Order. Hubert. That's right, class. I know what it is. Y'all hate me. That's what it is. Why y'all hate me? What'd I do to y'all? Give me the silent treatment? Guys, get used to that. And nobody says anything. Is somebody in there not letting y'all talk? Is that what it is? There's somebody in there telling y'all not to talk to me? Is that what it is?
No.
Huh? Well, y'all people that are at home that's got the COVID, y'all can talk to me.
You have a work email.
Uh-oh, somebody done complained. All right, so ordinal means order. What else? Well, there's interval. Interval means what? Means numbers that can do operations. Interval means numbers that can do operations. What do you mean? Well, temperature. If I tell you today is 50 degrees and tomorrow is 50 degrees, then the average of those 2 days is 50 degrees. Does everybody understand that? So I can do operations with the numbers. So that's a good example. Temperature is a good example of interval measurement. And ratio. Poor old ratio. Poor old ratio. 0 means none. Does anybody work? Anybody have a job? Mr. Dickerson or Mr. Hamby, do you have a job? Okay. Mr. Hamby, do you have a job?
Yeah,
Where do you work?
I just do lawn care stuff.
Okay, let me ask you a question. Let's say that you don't go to work this week. What will your paycheck be?
0.
Okay, then that means that's a ratio measurement. Okay, because 0 means you broke. All right, so your paycheck is a ratio and nominal. Temperature is interval and nominal. Who won the game? Seneca. Who lost the game? We
Mustang.
won't say, but that could be ordinal. Who came in first? Who came in second? That could be ordinal and nominal. So I want you to make a note of this for your standardized test, but I will not test you on this. Okay, I don't usually test on that, so you need to make a note of that, and we'll keep going. And I'll give you an example. Here's examples of each. There we go. Write them down. Oops, I'm sorry. There's you some examples. If I could get if I didn't have it turned up so much so you could see it, I wouldn't have to do all this. So you're welcome. There you go. Gender, you can do that as nominal. Whichever thing is nominal. Temperature is ratio. I'm sorry, is interval. Number of days that you studied for a test. That would be ratio. And letter grade in the class. That would be ordinal. Question, gripe, complaint. Yeah, Hubert, we understand. Good. Let's keep going. Good. And that's 1.1. So as of today, you are responsible for 1.1 homework or send questions. So let's move on. 1.2. As soon as I can find it. 1.2. Observational study and experiment. I'm gonna let you write your own definition for observational study, but basically you watch, observe. You don't do anything. You watch or observe. Any of you ever seen videos on sleep apnea? People with sleep apnea? And they take these videos of these people sleeping. You ever seen those videos? Okay, well, that's observational. In other words, you're being recorded to see if you sleepwalk, to see if you wake up in the middle of the night 15 times, to see if you stop breathing. Okay, that's observational. That's an observational study. That's a good one to write down because as an example. Now, let me ask you this. What if I took a cattle prod and every time you moved while I was watching you sleep, I hit you with that cattle prod? Is that observational or is that experiment?
Experiment.
Why? Because what? What did I do different?
You're like interacting with the
I'm
person.
interjecting something into the observation. Write that down. The difference between an observational study and a experimental is experimental, you interject something into the observation. You got to say this. Some of my techniques are unconventional, but it makes you stick. You remember that cattle prod. Some of y'all don't even know what a cattle prod is, but we don't even have any. And we've been fooling with cows for 3 generations, and we never have used cattle prods. Never. Dang old feed bucket takes care of our cows. You can lead our cows anywhere with a feed bucket. Lurking variable. What is a lurking variable? If I can hit the right buttons. What is a lurking variable? Now that's a test question, and observation and experiment is a test question. What do you put beside lurking variable? Something that is not considered. Something that is not considered. I'm going to let you write that down, but I'm going to give you an example, a good example of something not considered. Let's say that I'm doing a study, and I'm doing the study on drowning deaths and Rocky Mountain spotted fever. Drowning deaths and Rocky Mountain spotted fever. And I find out that, let's see, January, February, March, January, February, March, April, May, June, whatever, April, May, June, July, August, September, October, November, December. I guess that's right. And I find out that it looks something like this. And then I do the Rocky Mountain spotted fever, and I find out that it looks the same in June, July, August, and September, they're the same. They're not the same deaths, but they increase during June through September. What's the lurking variable of these two things that are happening? One's in water, the other one's on land. You can't get Rocky Mountain spotted fever by swimming. But what do they have in common? That means I want somebody to give me a, guess or a
Death.
death. Yeah, they do. Yeah, death. But that's not water freezes in the cold seasons. There you go. You're getting there. Come on. Keep going. What's the lurking variable with these two things?
Summertime.
Summertime. Warm weather. Why would warm weather be a lurking variable? Well, what do people do in warm weather? They go swimming and they go hiking, or they go camping. So the lurking variable is warm weather. That's a, lurking variable. That's an example of a lurking variable. So let's go. A blah, blah, blah was not considered. Not considered is your words to remember. A variable that's not considered but has effect. Okay? Question, gripe, complaint. No, Hubert, we're good. Thank you, class. I know why they're telling y'all not to talk, because it messes up the feedback, right? Yeah, that's it. I don't want y'all to not talk. I want you to talk. Not disrespectfully while I'm talking, but I want you to communicate when I ask a question. Census. Make sure you know what a census is. You need to write that down. I won't test you on it, but a standardized test will. Make sure you know what a census is. It's collecting data every 10 years. Here in the United States, it's collecting data every 10 years. But it's also a list of all individuals in a population. Now, everybody was talking about the census about a year ago. Does anybody know why? Come on, I know there's at least one or two of you that watch the news. I'm sorry, what?
The voting fraud.
Say it one more time, please.
Voting fraud.
Voting fraud. Oh, there wasn't no voting fraud. What are you talking about? Actually, you're right there with that, but they were saying that there was a big discussion about whether the question, are you a citizen of the United States, be on the census. I, for one, have a certain opinion about that. As a math teacher, yeah, because you want to know who is citizens and who are not. I mean, I figured that's the same thing as saying, are you male or female? As a math teacher or a math person, I would want to know that information. And they also asked, I think, legal citizen and things like that. And there was a big discussion on what should be on the census. And, I think, but some people say it shouldn't be on there. But what does it say? A list of all individuals in a population along with certain characteristics of each individual. So you can, come to your own conclusions there, but I think if you're doing a national survey, I think you ought to include whether you are a citizen or not. That's just my own mathematical opinion. And you are right. Voter fraud was about that also. And that's 1.2. So now you are responsible for homework on 1.2. And these go kind of fast because it's definitions, okay? It's not math, so we're going to go kind of fast. Random sample. That is a test question and a standardized test question. It will be on every standardized test that you take. What is a random sample? Well, there's only two words that you have to remember. Equal chance. Write that down. Equal chance. A random sample means everybody has equal chance of being picked. Do y'all know I can put y'all in separate what do you call it, teams? If I want to break y'all up into teams, y'all know I can do that with teams. I'll show you right here. I can break y'all up into breakout rooms. Did y'all know that? And you know how you do that? You tell teams that you want to break everybody up into different breakout rooms, and it will pick y'all what? What will it do? It will pick y'all randomly and put y'all in separate rooms. Randomly. It will pick you randomly. That means everybody has the same equal chance of being picked for a certain room. So, somebody give me an example of random sampling. What is the most common example of a random sampler?
Putting names in a hat.
Exactly. Write down each one of your names on a Post-it note. Fold the Post-it note in half, put it in a hat. Pick it. Write that down because that is a test question. What is an example of a random sample? Now let me ask you a question. What if you have 10,000 people? Then you need to use something else. And I'm going to write that down for you. Random sample. Names in a hat. And we all know how to do that. And you throw the names in a hat and you pick one. But what if you have more? You have a table that you can use, and you have a generator that you can use. Now I'm going to show you the generator right quick on your handy dandy calculator. And I want you to hit math, or just write this down, math, go over to probability, and go down to number 8. That means random, and I can't remember what INT means, but no repetition. Random and integers with no repetition. So let's say that there are 30 people. I put a number beside each one of your names. Everybody with me? I put a number beside each one of your names. So there's 15, there's 14, somebody left the class. Did somebody leave, yes or no?
Felicity
Somebody
got
left.
quarantined.
I'm sorry, say again?
Felicity got quarantined
Okay. Okay.
just now.
Well, what I'm saying is somebody actually left the class in the last few minutes because it was 15 students. Okay, well, don't worry about it.
Yeah, she had to go home.
Okay, she had to go home. Oh, okay, but she was here. Okay. All right, so probability, and I'm gonna go down and hit 8. And my first 1 through 30, because I 1 through 15, I put a number beside each one of your names. And I want to break you out in groups of 4 or 5. Let's go with 5. And it will generate, and hit enter. So the 15th name, the 5th name, the 2nd name, the 1st name, and the 11th name, I'm going to pick for that first group. That's called a random generator. Hit second entry, do it again. And there you go, 1, 7, 5. Now it did repeat, but that's just 2 different things. Okay? Each time you do it, it's going to be different numbers. So if I want a group of 5 students out of this group, and I put numbers beside each one of your names, then I'm going to pick the 15th person, the 5th person, the 2nd person, the 1st person, and the 11th person. This is called a random generator. Now, what about the table? Well, I'm going to show you how to use the table right now because you're going to see it in the homework, and it's going to slow you down a little bit. Now, some of y'all wrote the table probably, but some of you may not know how to use it. So let me go to, I think it's number 7. And these are somewhat new questions. They're new questions. I've never seen these questions before, but they were sent to me from one of the other classes, and I had to familiarize myself with it because I've never seen them before. And I have several degrees, and I admit that I don't know something. That's the difference between somebody that thinks they know everything and somebody that doesn't. So you click on the table, and there is the table. So I want you to write that table, kind of sketch it down. Go ahead and write that table right quick. I'm going to give you a few minutes to write it down, please. I can't blow it up anymore. I'm sorry. Now, a lot of you may say, well, where did the table come from? Well, pretty much a random generator, but I'm not going to. And I'm going to try to write this table down with you. So we've got six rows, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6. Oh, this is going to be a pain. 9, 8, 5, 9, 8. 9, 8, 5, 9, 8. 1, 1, 3, 4, 8. 7, 4, 0, 6, 5. And 2, 1, 6, 2, 0. And 3, 6, 9, 4, 6. The reason I'm taking the time to do this, and you should be taking the time to do this, is out of a class of 14 people, 10 people sent me this question. Okay? Because I didn't know it was in there. I didn't know it was in the homework. So this new on me. 64824 10372 and 60538 21249 91787 44603 05473 55987 06029 06029 34829 and 07689 22047 42968 15149 and 17136 02973 94533 37070 13553. And I'll also tell you another little secret. I've been, I graduated Clemson in 1994, and I've been teaching since then. This is the first time I've actually seen, 2 or 3 days ago, the first time I've ever seen a random table. Okay? Does everybody understand what I'm telling you? It's something you don't see very often. So I'm just letting you know, if you do this homework problem and you've never seen it before, well, you're not the only one. Now, the question says, community college, blah, 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 89 full-time members. So that means 1 to 89. The numbers you're looking for, you're putting a number beside each faculty member. So that means you can't go below 1 and you can't go above 89. I need you to write that down somewhere in your notes, because they're telling you what to do here. So 1 to 89, and they want nine faculty. They want to pick 9 faculty members. Okay, now when you use a table, you have to have somebody to throw a dart or drop a pin and hit a number. You got to have some kind of, drop the pin and whatever number it falls on. Does everybody understand that? When you use a random generator, I'm in a random table, and I'm going to put this in green. You've got to have a point. Okay, I'm writing all this down for you. Just hold on and I'll switch it over. Now, here is the point right here. Row 3, column 6. Row 3, column 6. And they give you that. So here's what we've got. Now, I know some of you are still writing, and that's good. I'll wait one more minute. Got to mix up my breakfast. I don't know why things can't stay mixed up in moonshine. No, this is not moonshine. I'm just joking. Somebody will go to my department head. Yes, Hubert was drinking while he was teaching the other day. Red Solo Cup. Did I tell y'all we had a teacher that did the Red Solo Cup thing? Did I tell y'all that? Every morning he got fired. Every morning, 8 o'clock, he would start. I mean, this guy was hardcore alky. I mean, he would drink at 8 o'clock in the morning. Red Solo Cup, teaching history. He had 5 classes and would fill that sucker up, go outside and fill it up out of his car every class break, after every class. By 1 or 2 o'clock, he was smashed. I mean, he was totally. Of course, he got fired. Can you believe that people with degrees are that stupid? We had one teacher, he decided to do illegal substances and leave his office door open while he was doing it. Stupid people. All right. Somebody tell me how many digits we're dealing with. 2 digits, right? Everybody with me? 2 digits, 1 to 89, right? Okay. All right. The point is 3, 6. Row 3, column 6. So there is your number that you're starting with. That's your point. And then you just start going down and you pick numbers from 1 to 89. So I take my green highlighter and you got to get 9 of them. So 6, 42. Can I use 94? No, 94 don't exist. You only got to 89, so you can't use 94. So I'll color that with an X. Go back to the top, up here, 34, 82, 78, 2, 96, can't use 96. And 53. Let's see how many we got. We need 9. 1, 2, 3, 4, 5, 6, 7. And go up here. 74 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you would pick the 6th person, the 42nd person, the 34th person, the 82nd person, the 78th person, the 2nd person, the 53rd person, the 74th person, and the 10th person. This is a random table, so make sure you write that down because you will have a homework question. I will not test you on a table. I'm not going to test you. I will test you on how you can use the calculator, and I will test you on what is a good example of a random sample, names in a fishbowl, names in a hat. I'll test you on that, and I'll test you on using the calculator. So let's do this one. Math, probability, random, 1 to 89, and 9 members. Will my numbers be the same as the table? No. That's the thing about random. It's not going to be the same. So I'll hit enter. And there's that's what the calculator generates. Everybody good? You're welcome. Because I'm going to tell you, I'm going to be honest with you. When I saw this question, I was like, what? I really, honestly, have never seen this before. And I've been teaching for years. So I don't know where they dug this up or where they, I just never seen it. Anybody ever seen this before? Yeah, I didn't think so. Of course, I know somebody probably invented it, but I'm not going to get into that. All right, so let's move on. That's 2 test questions. 1, what is an example of a random sample? And 2, make sure you can do it in the calculator. If you can't do it, then you're just a loser. All right, let's move on. Yeah, Hubert called me a loser. Yeah. I just picked you out of the whole class and called you a loser. I didn't generalize at all. I just picked you out. United States of pansies, buttercups and snowflakes. No sense of humor, none whatsoever. Can't laugh. Can't pick on each other. Next. Where is my, there we go. Now, what is the difference, and this is another test question, what is the difference between a simple random sample and a random sample? Anybody want to volunteer that one? What is the difference between a random sample and a simple random sample? Okay, nobody's going to jump at it. A random sample, as I said before, each individual has equal chance of being selected. All right? That's Sweet Home Alabama for some of you that parents, it's their fault. Okay? I switch between Guns N' Roses and Sweet Home Alabama, so. And sometimes I'll throw some Eagles in there. And if you don't know those 3 bands, it's your parents' fault. And it's really sad that you don't know those 3 bands. And AC/DC. Did you know AC/DC was actually from Australia? I didn't know that. I'll shut up. Simple, random sample. There's only one word that you have to change between these 2 definitions. Anybody know which word it is? Each group has equal chance of being selected. A simple random sample is, let's say I take Miss Poor, Mr. Scoggins, and Bridwell, and I call them Group A, and I put their names on a piece of paper and put Group A on that piece of paper. And then Newsom, Bowen, Landreth, and Williams, I put y'all's name on a piece of paper, and I call you Group B. Lopez, Ferguson, Jarrett, and Dickerson, I put your names on a piece of paper and call that Group C. And then Woodson, Tim's, Hamby, and not me, but I put y'all on a piece of paper and call you group D and put those 4 pieces of paper in a bowl and pick one. That is a simple random sample. So what is the difference between a simple random sample and a random sample? Random sample is individual. Simple random sample is group. And I guarantee you, some of you sat through a probability class and didn't know that. Next, what is a systematic random sample? And why am I teaching from home today and not teaching for Anderson campus? My truck, I'm getting a, what do you call it, getting a fast pump put on my truck because it keeps blowing my internal pump. So I'm getting an external pump put on it. So that's why I'm at home. And I don't want to drive the maintenance truck. I got a maintenance truck in the yard. I don't want to drive it because I don't want people trying to steal my tools. So, and I didn't want to go to the Anderson campus today, main reason. Systematic random sample. What is a systematic random sample? Anybody want to take a guess? No, Hubert, we're good. Okay, thank you, class. Y'all are exactly that date you take to a very nice restaurant and all they order is a glass of water and a salad. That's what y'all are. Y'all being that date. All right. And if you haven't had that date yet, guys, you will. You wait to see what I tell you. Go to the freaking Outback. No, I just have a water and a salad. Whatever. Let's get this over with quick. All right. Systematic random sample. Systematic random sample is every nth individual has an equal chance. Let's say I tell you to go outside Palmetto High School, front doors, and every 5th person that comes out of the doors, you ask what their favorite color is. That is a systematic random sample. Now, why do I have these 3 together? Because they are the most what? Most used as far as individuals. Most used. Well, what about the other 2 or 3? Well, convenience sample you shouldn't use. So you can write that down. Convenience sample you use the least. Convenience sample is the most inaccurate. So let me ask y'all a question. If I let y'all go late, well, I don't want to keep you late because you have to, but if I let y'all go early, do y'all have like people pouncing on y'all, getting mad at y'all for be letting y'all out early or what? Okay. All right, because I was teaching the Crescent class the other day, and I let them out go 5 minutes, and there was somebody in the room going, "Where y'all going?" And I'm like, "Uh-oh." So I don't know. I figure if you're taking dual enrollment, then that means that you're probably making pretty good grades. Why would they think you're going to cut school or something? Anyway, they're the most used. I'm going to try to get through the last 2. And I'm going to go ahead and let you see those last 2. And they are stratified and cluster. And they probably put it in another section. Let me see. They're doing random generators here. There's technology right there. So you might want to look at that. There's random generator, and I'm not using that. Okay, 1.3, that's where you see there we go, stratified. Stratified, write this down. This is where we're talking about groups. Stratified is everybody is similar. Let me give you an example. What if I was to survey all kids in the first grade in District 5? I go to each elementary school and I asked every single first grader what their favorite color is. Then that is a stratified because all of them are what? In the first grade. And if you're in the first grade, you're the same what? Age. So these kids are the same age. So that's what they have in common. They are the same age. So stratified into non-overlapping groups called strata, and then obtaining a simple random sample from each stratum. And then there's cluster. A cluster would be like a voting precinct. Well, they're not similar. Why not? Because you can be 18 to 107 to vote. As long as you're over 18. Where's cluster? Let me find cluster. There it is. I like to call it a voting precinct. Do they have anything in common? The only thing they have in common is they're voting. That's the only thing they have in common. They're not the same age. They're not the same gender. They're not the same race. They're not the same party. Now, if you go inside the cluster and then you do stratified, then you can break the cluster up into male and female. You can break them up into Republican or Democrat, independent. You could break them up into, but a cluster is just going to a voting precinct and asking people what their favorite color is. And then the last one, which is the least used, is convenience sample. And it is the least used. There it is. Because it's the easiest to obtain. Oh no, I got the COVID. Let's say that I worked at a rock station and I was a DJ at a rock station and I go to school part-time and I'm taking a Math 120 class and I need to do a statistics project. So I decide to holler out to all my people that's listening to my radio station. I say, what kind of music do you like? Somebody tell me what's wrong with that.
They're going to say rock because it's a rock station.
That's called a convenience sample. That's like hollering outside your window and asking a guy that's walking whether he likes to stay in shape or not. Well, it's 6 o'clock in the morning and you're hollering out your window and there's a guy on the sidewalk walking at 6 o'clock in the morning. What do you think his answer is going to be? Yes, I like to stay in shape. That's why I'm walking at 6 o'clock in the morning. That's a convenience sample. Very, very inaccurate. It says that right here. All right, I just covered 1.1 through 1.3. So what does that mean, y'all? Oh, I'm sorry. 1.3 through 1.4. So that means today I meant Thursday, you should have 1.1 through 1.4 homework either completed or 80% completed with questions sent. Does everybody understand that? And probably, since it is reading and since it is definitions and there's no math involved, except for that little bit of calculator work and table work, I'll probably put a date on the homework of 1.1 through 1.4 as we get closer to Thursday. So chances are you're probably going to have a cutoff date, probably that Thursday or Friday. I don't know yet, because I'm going to make sure y'all stay up with the homework, because out of every class, there's one or two that's going to wait until, you know, the day that I give them, and they're going to try to do all the homework then. So I'm trying to keep y'all up to snuff. Now, I think everybody was here today, wasn't there? Wasn't everybody here? There was 15 people. I think everybody was here, correct? So, any questions for me? Unmute your mics and ask me a question if you got any. All right, since everybody was here, all I need to do is go in and put everybody was present, so that's easy to do. I don't have to call the roll. And y'all have a good day, and I'll see y'all Thursday, okay?